Good morning to you all. I will have a very brief talk on just starting study dealing with the usage of small satellites and nanosatellites for multi-point observation on planetary environment. I'm not Nicolas André, as it is written on the slide, because Nicolas apologized for sudden unavailability and André Laurens spontaneous and I'm at this group talk. The scientists dealing with planetary environment study are very fond of multi-point measurements in order to probe 3D or 4D the space around. And unfortunately, big missions such as next Colombo or cluster for solar physics have become too expensive to be foreseeable in the coming years or decades. So the purpose of the study is to analyze the capabilities of nanosatellites to bring a new solution for this multi-point observation, mainly for internal planets on the solar system. So this is a phase 0 study conducted in the early project study team, using Palaiseau and the idea is to study a concept, rather general concept, based on a mothership and several nanosatellites centered on a typical mission profile we have to set up. Evaluation of orbits appear to be propulsion power resources needed for such kind of mission, and go through the design of one typical nanosatellite for this kind of mission, knowing that 30 kilogram satellites is another bound of what we intend to study. And I see next slide. There are some typical science cases that would be addressed by such a concept. First is how to study how a solar event is propagated through a magnetosphere, and typically you need a first nanosatellite ahead from the magnetosphere for the planet, dedicated to the pure solar event study, and some trailers nanosatellites in the magnetosphere to study the echo of this event and evolution through the magnetosphere, with possibly a sounding capability for instance, by means of computation with a mother spacecraft with a certain channel. Another case would be the study of the process of the planetary magnetosphere. A typical case is Mars. That's why it's called the talk was entitled Mars Magnetosphere, but for the moment the target planet is not selected, but it could be Mars. Also, this science case needs at least 3 measurement points, so 3 nanosatellites typically. For the characterization of the different regions in the magnetosphere. Another one would be the study of the interaction between the internal structure and the magnetosphere. There are also at least 3 points of measurement will be necessary to conduct this investigation. So the typical emission scenario would lead to one dedicated nanosatellite to Sorbonne, other for magnetospheric and in situ measurements, and another ship as a cruise module, as a telemetry relay to Earth, but also why not as a help for its determination and so on of the nanosatellites. So the study will need to first define one or several missions scenario, envisage the orbits, the capabilities needed for the cruise module and for also the various nanosatellites to build this formation, this constellation to have the measurement done, and we'll try to go to the dimensioning of the nanosatellites in terms of equipment's weight, particularly electromagnetic cleanliness, and of course a cost estimation, since it's always required now for mission proposals. Yes. So the kind of question we'll have to solve will be: are the nanosatellites all identical or specialized, either on an instrumental point of view or either in a satellite point of view? For instance, very often this kind of satellite are spinners. Are they all spinners, or are they 3-axis controlled satellites? Of course, which orbits which trajectory? And a very tough question is magnetic cleanliness. There are also other studies ongoing in this to characterize nanosatellites equipment against this concern. So the purpose of the study is not exactly to demonstrate the interest of multiple measurement, because scientists who deal with that are convinced that multiple measurements are necessary to make significant progress in science, but to demonstrate it's feasible with nanosatellites, because as I often say, either we know how to do, we can do it with nanosatellite, either we cannot do at all for budget, for money point of view. And at least the idea is to push the nanosatellite as a whole, nanosatellite plus instrumentation, as a dedicated payload that could be put on a main mission as a passenger and developed and operated and designed, of course, independently of the main satellite. And so for me, thank you very much for your